I'm Larry, the Old Gazer. This is the Old Gazer channel, which of course is for inexperienced, beginning amateur astronomers. And the goal of this channel is to try to provide some hints, some suggestions, some practical information to help those of you who are new to this hobby as you move into and work your way towards becoming an amateur astronomer. So welcome, that's what we're all about. Before we begin today's video, just a couple of words, if you will. First of all, I want to thank everyone who's viewed these videos. Especially want to thank all my subscribers. And I appreciate very much all the comments that you've taken the time to include on the channel. I've enjoyed reading those very much, and hopefully I've responded to all of them, or if I haven't, I'll try to do so soon. So thank you very much for that. Secondly, I just want to iterate something that I know I've probably said several times during the course of these videos, but it's something that bears repeating, and that is amateur astronomy has a great deal to offer. I'm pardon me, I'm partial, I know, but I happen to believe that this is the best of all hobbies. It's inspirational, it's exciting, it's all of those things. It has a lot to give, and it will give a lot, but please understand, if you're new to this, and I assume most of my viewers are, you have to put something in as well. And as I've said many times, the hobby requires patience, and it requires doing the right things the right way, and it takes a lot of practice. You've got to spend a lot of time and invest quite a bit of your energy into learning the sky, learning how to find things, learning how to use a telescope, learning the art of viewing things through a telescope and those kind of things. It's a hobby with a learning curve that actually never ends. I mean, it hasn't for me after all these decades. There's always something new to learn, something new right around the corner that's going to be exciting to keep you going. But it does take a lot of practice. I think I said once before that in order to really enjoy this hobby, you've got to get to that point where you kind of know what you're doing a little bit. When a lot of these things become second nature to you, learning the sky, operating your telescope, learning how that all works. When you've got to that point, then you can really begin to focus on viewing these objects and learning about this marvelous universe in which we live. So I say all of that to say this. Don't just go out for 1 or 2 nights and get discouraged or disappointed and decide that maybe this isn't for you. Give it an honest try. You got to stay with it for a while. It takes some time. It takes a lot of practice. It takes patience. It takes doing the right things the right way. But as I said in the beginning, if you're willing to put enough into it, this hobby will return many times over in terms of inspiration, in terms of excitement, in terms of abilities to be educated about this universe and helping us find our place within this universe, which is really, when you get down to it, what it's all about. So just a word of encouragement there. Don't think that you can invest a couple of nights viewing and think that you've seen what it's all about. You've got to put in a lot of time. You've got to put in a lot of practice. You've got to get to that point where you kind of know what you're doing before the hobby will really open up things for you. And it has a lot to give if only you will persevere and let it do so. Okay, so just wanted to give you a little bit of that kind of encouragement before we start. Okay, enough of that. I want to talk about mounts in this video. Now, we've talked about mounts a little bit in previous videos, particularly in the 3 series segment that we did on telescopes, but we only kind of touched on mounts as, insofar as them being a part of your telescope system. I want to go into a little bit more detail concerning mounts in this video. And again, it's going to be very high level. It's going to be intended for people who are inexperienced beginners, and I presume that's who most of you are. And so if you already know a lot about this subject matter, you may want to do something better with your time. So anyway, let's talk about mounts for a while. So what is a mount? Well, a mount is the device that sits between your tripod, or in the case of a Dobsonian telescope, the ground or whatever table or whatever flat surface you might have your Dobsonian sitting on. It's the device between the tripod or the ground and your optical tube assembly. It's in this telescope, this is the mount right here. For this telescope, this is the mount right here. And for this very small refracting telescope over here, this is the mount. Now, I don't know how well you're going to be able to see all this. My studio here is a little bit crowded and I have trouble getting everything in here. But hopefully you can see enough to kind of follow along with what we're going to be talking about here today. So that's the mount. Mounts, of course, are the devices that enable you to move your telescope around and point it where you want it to be in the sky. It's how you find objects, you get them in the field of view of your telescope, it's how you watch them. Now, mounts can be extremely simple, elementary actually, very simple in concept, very simple in operation, or they can be pretty complex, as we're going to see as we go through this video. They can be manual, that is, you operate them purely manually with your hands, or they can be motorized, computerized mounts that have motors and gears in them that can help you find things in the night sky and more importantly, can help you track the apparent motion of things across the night sky as you attempt to view them or image them, okay? So, I want to talk about the two basic kinds of mounts that are used by most or perhaps all amateur astronomers. We'll talk about what they are, how they work, what the differences in them are, and maybe what the advantages and disadvantages of each of these types of mount are. Now, I'm going to break this into two segments, and I'm going to try to make it, not so long that you'll go to sleep or drop away and go do something a lot more fun than watching me flap my gums on this video. But first of all, I want to talk about the function of mounts purely from the perspective of a visual astronomer, someone who's only interested in observing and viewing objects through the eyepiece of the telescope and who really doesn't care much, if at all, about taking pictures, taking photographs through the telescope. So for right now, let's confine our comments about mounts to how they relate to visual astronomers within the context of visual astronomy, if you will. Now, one type of mount is known as an alt-azimuth mount. That stands for altitude azimuth, and it's so called because it moves in two directions. It basically moves in a vertical direction, which is called the altitude axis, and it moves in a horizontal or panning direction, which is the azimuth direction. Altitude and azimuth have to do with how to locate objects in the sky. And an alt-azimuth mount helps you do that by enabling you to proceed, move that mount, that telescope, along the correct azimuth and to the right altitude so that you can get that object in the field of view of your telescope. Now, these are very, very simple. Let's take this one, for example. This is an alt-azimuth mount on this little refracting telescope, and you can see it functions extremely easy. You do like that to move the telescope tube up and down, and you do like that to move it around and, along the azimuth axis. So with those combination of movements, you can literally point that telescope anywhere you want to point it in the night sky. And that's a very, very easy, very, very fundamental to use. This telescope also has an alt-azimuth mount, but this happens to be one of those computerized telescopes that I referenced earlier. These are customarily called Go-To telescopes because they have gears and motors in there that can be used to let that telescope literally find things for you in the night sky, get them in the field of view, and then track them as they appear to move across the night sky due to the rotation of the Earth. So this is a motorized or computerized Go-To alt-azimuth mount on this telescope. The principle is the same. It moves up and down this way and back and forth this way. It's computer controlled, and you control its movements with this hand set here. But same principle. It goes up and down, and it goes back and forth, and with some combination of those two movements, you can literally point it anywhere you want in the sky. So those are alt-azimuth mounts. This telescope has what's called an equatorial mount. Considerably more difficult to understand, more difficult to use, at least until you get used to it and become comfortable with it. A little more difficult to get set up, but it has some advantages, and we'll talk about what those are in a moment. This equatorial mount it moves along two axes, just as a alt-azimuth mount does. But the two axes along which this one moves are called the axis of right ascension and the axis of declination. Now, those two terms define the object or locate objects for you in the night sky. They're at a certain declination and they're at a certain right ascension. Now, you can think of right ascension and declination as being analogous to the terrestrial concepts of latitude and longitude. You know, latitude defines the number of degrees above or below the equator. Longitude defines the number of degrees or hours from a specified location on the Earth as you go around the planet. The same with these. This declination axis right here is analogous, to latitude in terrestrial terms, and the right ascension axis is analogous to lines of longitude on the Earth. So that's how that works. You move it along the declination axis by simply turning it that way, the declination axis being right here. You move it along the right ascension axis by simply rotating it like that. And so by those two motions, you're able to find and locate objects in the night sky and get that object within the field of view of your telescope. Now, here's where it starts to get a little bit complicated with this kind of mount. This mount, in order to function correctly, has to be polar aligned. You may have heard that term before. If not, that may be a new one for you. What in the world is polar alignment? Well, in order for this equatorial mount to function and do what it's supposed to do, you have to align it in the northern hemisphere with the north celestial pole. And in most cases, that means aligning it with the star Polaris, which we in the northern hemisphere are very fortunate to have as something very, very near the north celestial pole. So this is the axis of the mount right here, and you have to align this axis of the telescope so that it's pointing at Polaris, pointing at the north celestial pole. And once you get that aligned with Polaris, then you don't touch this. You don't move the tripod or you don't move the mount anymore. All of your movements after that time are moving the declination axis and along the right ascension axis. As you can see, the mount itself is not moving at all. Now it's only the optical tube that's moving here. Once you get this aligned with the North Star, you don't touch anything anymore. That has to remain the same. Now, I'm not going to go into the process of how you do a polar alignment. It involves getting your telescope set to the right latitude from where you're going to be observing. And you just get everything lined up properly so that this axis of your telescope is pointed at the North Star. Maybe we'll do another video on that later on, or you can research that at other places on the internet, on other YouTube videos. But this one has to be polar aligned. Now, there is an advantage, however, to having a telescope that's polar aligned and that moves along dimensions of declination and right ascension like this one does, and that is, once you get an object in your field of view, in your telescope, you can keep that object in the field of view just by making small adjustments using this slow motion control cable on the right ascension axis only. Yeah, I don't know if you can see the telescope moving or not when I'm turning this knob, but that's the way it works. You only have to move one axis. Move your telescope along one axis to keep an object in the field of view if you've done the proper polar alignment and you've got that set up correctly. And so that's the advantage of this. If you're using just an alt-azimuth mount, and again, we're in purely manual mode here, or visual mode, pardon me. Once you get the object within your field of view, you have to constantly manually move the whole telescope up and across and down to keep that object in the field of view. With an equatorial mount, you only have to move it along the right ascension axis, and once you get it in the field of view, you can keep it there just by making fairly small adjustments with this slow motion control knob right here. So that is the advantage of an equatorial mount. Now, if you've seen my previous videos, you will know that I strongly recommended that inexperienced beginning amateur astronomers start out with a simple alt-azimuth mount for obvious reasons. It's very easy to move it around that way. You don't have to worry about polar alignment or getting used to the fairly, to the methods of moving this telescope, which definitely takes some getting used to. You just don't need that as part of your learning curve if you're very new at this hobby. I continue to recommend an alt-azimuth mount for beginners, and in fact, let me say this. Now, this is my own personal opinion based on my experience with these different kinds of mounts. If all you're going to be doing is observing objects or viewing objects through an eyepiece, if you're just a visual astronomer and you're not concerned with taking photographs of objects in the night sky, I personally don't see why you would ever want to use anything other than an alt-azimuth mount because they're so much easier to use. They don't require the polar alignment. They're very intuitive. I mean, you don't even have to think about moving this thing back and forth and up and down to get it pointed at the part of the sky that you want it to point at. Whereas with this, that can be a little more tedious and a little more difficult. And that can be an obstacle that might stand in your way and might frustrate you a little bit. Try your patience when you're trying to learn the night sky, trying to learn how to view things through a telescope. So honestly, those of you who may have Dobsonian telescopes, they move around by hand for the most part. You can get a motorized Dobsonian telescope, but normally they're purely manual, and it's very intuitive and very easy to learn. The base turns around like a lazy Susan to move the telescope along the azimuth axis, and then you just tilt the tube up and down to get it to move, to change the altitude, and there you are. Just very intuitive. It becomes second nature very quickly to use an alt-azimuth mount, and if you're just a visual astronomer, the only advantage to this is that once you get an object in the field of view, and assuming you've got it properly aligned, then you can keep it in the field of view with small adjustments using this slow motion control cable here. And that's an easier way to keep things within the field of view. But to me, the other aspects of this, the need to polar align it, the requirement to get used to how it moves and that kind of thing, the increased complexity of this does not that outweighs me the advantage of just being able to use the slow motion control cable. That's my perspective. That's my opinion. I think a visual astronomer would probably be better served to stick with an alt-azimuth mount rather than the equatorial mount. So, that's looking at these mounts from the perspective of just visual astronomy, or just observing and viewing objects in the night sky. Now let's talk about which one of these mounts is better for taking pictures of objects in the night sky. And before we get into that, I need to discuss with you a little bit about how objects move in the night sky. Now, of course, objects don't move in the night sky unless it's a comet or something. They appear to move because of the rotation of the Earth. Now, we all understand that, I'm sure. So it's apparent motion. It's actually the Earth moving and not these things that we're looking at in the night sky. But, you know, for purposes of simplification in this video, I'm just going to refer to objects moving across the sky. Even though they're not really doing that, it's the Earth that's moving underneath them. It's just easier to talk in terms of these objects moving across the sky. So that said, let's talk about, you know, the way I look at it, there are three components of movement as an object moves across the night sky. And let's talk about those three for just a moment. Let's assume a hypothetical nebula here. Let's call it Nebula X. Purely hypothetical. We're going to use it as a hypothetical example. Let's assume that Nebula X rises in the east in the early evening. It passes up across the sky, transits the sky, reaches a zenith, and then starts down the other side. And somewhere in the early morning hours, it will set in the west. So that's our hypothetical situation there. An object that rises, transits the sky, sets in the west. There are three types of motion going on as that object transits the night sky. The first of these, the first component of that motion is a vertical component. As this object rises in the east, it is, of course, moving up into the sky. That's the vertical component of motion. It is also moving in a horizontal way because in addition to rising up, it is also going to be moving across the sky. So you've got a vertical component of motion, a horizontal component of motion, and those together will, you know, allow you to follow the object up and across the sky during the night. And those two motions can be tracked equally well by an alt-azimuth mount or an equatorial mount. No problem at all. Even if you're taking pictures and you only had those two types of motions to be concerned with, a vertical and horizontal component, you could take pictures with both of these mounts equally well. However, there is a third component of the motion of an object as it transits the night sky, which is called field rotation. And if you will forgive me using my fist as a visual aid here, let's look at how this object really behaves when it moves across the night sky. Over here in the east, it rises up and it starts its trip across the sky. But as it's moving up and across the sky, it is also rotating, as hopefully you can see my fist rotating here, constantly changing its orientation as it moves up and across the night sky. So by the time it gets over here, it's in a completely different orientation from where it started. That rotation, that movement is called field rotation, and that cannot be compensated for by an alt-azimuth mount. An alt-azimuth mount has no ability, no capacity to compensate for field rotation. So now that we've covered those types of motions of an object in the night sky, I think you may be already able to determine that an alt-azimuth mount might not be the best mount to take pictures of objects in the night sky because those mounts cannot account for the field rotation of that object as it passes through the sky. And that would certainly be true. Now, if you're taking pictures of the moon or the planets, this is not really that much of an issue because you're just taking, quote, normal pictures of sunlit objects when you photograph the moon or the planets. But when you get beyond the moon and the planets, astrophotography becomes a real challenge. And here's why. The rest of the objects that are out there for you to photograph are galaxies, star clusters, nebula, double stars, and so forth. These things are all, of course, very far away and very faint. That's why they're sometimes referred to as faint fuzzies. They just don't emit a lot of light. They're not sunlit objects like the moon and the planets are. So when you're trying to photograph these deep sky objects, here's the challenge. You have got to take long exposure photographs in order to gather enough light or enough signal to get a decent picture. But you've got to take those long exposure photographs of moving objects. I mean, these things are moving while you're trying to take long exposure photographs of them. And if you know anything about photography at all, or if you can even follow the logic of that, you can see why that is a conundrum. You know, that's a difficult thing to do. And so if you want to take photographs of deep sky objects, you would not want to try to do that with an alt-azimuth mount, because you're going to have to take long exposure photographs of at least, many seconds, if not minutes or more, in order to obtain enough light or enough signal from that object to get a decent photograph. And long before you can gather enough light, that object will have rotated enough in the sky that when trying to photograph through an alt-azimuth mount, you'll find out that the stars in your picture will now have started to trail or arc, because you've just exposed too long and to account for the motion of that object in the sky. So I hope that makes sense. Star trailing, star arcing, the movements, the blurring of stars in your photograph is going to occur after you have reached a certain point of exposure of that object. And unfortunately, with alt-azimuth mounts not being able to account for field rotation, that exposure time is going to be generally too slow with an alt-azimuth mount to give you any decent prospects of trying to take a photograph of a deep sky object. That's why you're going to need an equatorial mount to take photographs of deep sky objects, because equatorial mounts do account for that field rotation of objects in the night sky. The equatorial mounts can account for the vertical and horizontal components of movement, and also for the field rotation that's going on with objects in the night sky. Now, before we go on here and talk about how you use an equatorial mount to take photographs of deep sky objects, you can take some pictures of deep sky objects, some of the brighter ones, with a motorized Go-To mount, such as this one here. This is called a Go-To mount. It finds objects for you in the night sky, and then once it finds that object in the night sky, it will track it. It will track the vertical and horizontal components of that object's movement. It'll follow it across the sky as the Earth rotates. And since it is tracking and holding that object in your field of view, you can actually take some time exposure photographs with a Go-To motorized alt-azimuth mount. However, you're limited in how long you can expose, because even with a tracking mount, you will reach a point where the field rotation will start to cause star trailing, star blurring, star arcs, and that kind of thing. If you have a telescope like this and you have it perfectly aligned, which is to say, if it is sitting perfectly level on the ground, and if you have gotten your guide stars when you align to this telescope exactly in the center of the field of view during the process of alignment, and if you've done all the other steps of alignment perfectly, if you've put in the exact latitude and longitude of where you are, if you've put in the precise time of day and the date when you're out there viewing, if you've done all of those things very, very well, almost perfectly, you might be able to take a long exposure of up to about 30 seconds with a motorized Go-To alt-azimuth mount. Certainly no longer than that. And in practical terms, you're not going to be able to go 30 seconds most of the time. The longest exposure you'll be able to take with a Go-To alt-azimuth mount probably going to be realistically in the realm of 15 seconds, 20 seconds, maybe even less than that. And unfortunately, a 15 or 20 second exposure is just not going to be long enough to gather enough signal, enough light from these faraway, dim, deep sky objects to yield a decent photograph. So you can do some time exposure photographs with an alt-azimuth mount, but if you really want to get serious about it and you want to get good pictures or decent pictures, you're going to have to go to an equatorial mount in order to take pictures of these deep sky objects. Furthermore, you can't expect to take these time exposure pictures with a manual equatorial mount such as this one is, where everything is done manually. You know, you rotate it by hand along the axes. You use a slow motion control cable to try to keep it within your field of view. If you've got a camera attached to this telescope, you can't expose for long enough. There's too much movement going on. There's going to be star trailing. There's going to be all kinds of things going on. You can't photograph deep sky objects with a manually operated equatorial mount. You're going to need a Goto motorized tracking mount. Now, I don't have one of those, but it works the same as this. You know, it has a means to control its movements, and it has gears and motors inside it, and you can tell it to find an object in the sky for you, and it will begin to track that object. And now in this instance, it's tracking not only the vertical and the horizontal components of the motion of that object, it's also tracking the field rotation as well. So you can take a much longer exposure with an equatorial tracking mount, a Goto computerized tracking mount, by far than you could ever hope to take with an alt-azimuth mount. So if one of your goals or if one of your areas of interest, if you want to get involved in photographing deep sky objects, then you're probably looking at a Goto motorized equatorial mount somewhere down the road in your future, because that's the only way you can take those photographs. And it can be a money pit. You know, you can find increasingly sophisticated ways to take longer and longer and longer exposures by using things like guide scopes and doing auto guiding and buying more expensive, better mounts and that kind of thing. You can spend a lot of money if you get into that phase of astrophotography. I mean, you don't really have to. You can get some decent pictures with some budget equipment with long exposures. One of the things that's available these days to help with these long exposures of deep sky objects is something called image integration or image stacking. I'm not going to get into that here. That's got its own video coming somewhere down the line. Just let me give you the very basics here. You can take a number of exposures, long exposures, through a telescope, one right after the other of the same object, and maybe hundreds of such pictures, maybe even thousands. And then you use software that integrates or stacks all of those hundreds of pictures together and produces one stacked image that has a lot more signal, a lot more information in it, and a lot less noise in it than any of the individual pictures would have on their own. Much better picture, and then you can bring that stacked image into some photo editing software and produce, in some cases, just a really good photograph. So you can get away with taking 15, 20-second exposures or even less if you take enough pictures that you can stack together to increase the integration time and decrease the amount of noise. Using a motorized tracking mount, equatorial mount, especially one that's guided or uses a guide scope and has all the really good equipment associated with it, you can take minutes of exposure. And so you can take multiple 1 or 2 or 3 image exposures and then stack those together, and that typically will yield even more detail, more signal, less noise than if you take shorter exposures with an alt-azimuth mount or with a mount like this. So hope that made a little bit of sense anyway. If you're not interested in taking photographs of objects in the night sky, I honestly don't know why you would ever want to use anything other than an alt-azimuth mount, because it's just so much more intuitive, so much easier to use than an equatorial mount. If, however, you want to get into taking pictures of objects in the night sky, specifically if you want to try to photograph deep sky objects, which are very dim and which require long exposures to collect enough light or signal to produce a decent picture, then you will have to have not only an equatorial mount, but some kind of a Goto motorized tracking equatorial mount in order to produce such photographs. There just really is no way around it. That will require a considerable investment of money, and honestly, that's just the way it is. Okay? So, that's probably enough. I probably have really confused the issue with all of this discussion. I tried to bring it together there at the end. Simple amount for visual astronomy, or possibly even for taking pictures of the moon and the planets. Computerized Go-To equatorial mount for taking photographs of deep sky objects. That's basically what it comes down to. So it all depends on what you want to do with the hobby as to which one of these mounts you will eventually migrate to. And so you'll have to start planning on that. And if you're going to get into photographing deep sky objects, you better start laying some money aside right now, because that can be a frightfully expensive aspect of being an amateur astronomer. It need not be, but it's still going to cost you a good chunk of change, even if you try to go with budget equipment or used equipment or those kind of things. Still going to cost you some money to get into that. So you just need to be aware of that before you make that decision that you want to photograph deep sky objects. Okay? Mounts. Equatorial mount, alt-azimuth mount, that's what they are, how they work, that's how they're different. Advantages and disadvantages of each, what you will need depending upon what aspect of astronomy you want to get into. Let's wrap this one up. I'll be coming back again soon with another video. But for now, let's wrap this one up. And since we're in that time of the season, those of you that do celebrate something this time of year, whatever the nature of that celebration might be, let me wish you all happy holidays. And thank you so much for watching. And I wish you, as always, clear skies and good viewing.